In the vast cosmos, a cosmic drama is unfolding, and its stage is set on Betelgeuse, the fiery giant of our night sky. The shocking truth is that Betelgeuse might be on the verge of swallowing another star. But that's not all. The star's erratic behavior hints at an explosive destiny that could forever alter our night sky. What does its unpredictable behavior mean for our universe? Could the stories of similar mysterious stellar events from 2002 shed light on this supergiant's future? And is it possible to unlock the mysteries of Betelgeuse and predict the exact moment of its cosmic explosion? Join us as we dive to uncover the clues and mysteries that have left astronomers astounded. Have you ever wondered where the elements that make up our world, from the iron in our blood to the silicon in our computers, come from? These elements were not born during the formation of the Earth. Instead, they have an origin story that begins in the heart of stars like Betelgeuse. This colossal red supergiant, a fiery beacon in the night sky, is more than just a spectacle. It's a cosmic alchemist, churning out elements that are the fundamental building blocks of the universe. But what makes Betelgeuse, this giant among stars, so fascinating? It's not just its size or brightness, but the potential destiny that it holds. A destiny that could dramatically reshape our understanding of stellar evolution and galactic chemistry. Rumors in the astronomical community suggest that Betelgeuse might be on the brink of a cataclysmic event, one that could see it swallowing another star and possibly culminating in a spectacular supernova. This isn't just stellar gossip. Such events have profound implications for the universe as we know it. Now let's dive into the fiery heart of a star. The life of a star like Betelgeuse is a tale of nuclear fusion, the process that powers the sun and all stars. In the core of Betelgeuse, hydrogen atoms fuse to form helium, releasing energy that lights up the star. But Betelgeuse, much older and larger than our sun, has moved beyond fusing just hydrogen. In its core, heavier elements like carbon and oxygen are being forged, marking the later stages of its life. So, why should we care about what's happening millions of miles away in the heart of a star? Because the process happening in Betelgeuse is responsible for creating the very elements that make up our world. Every carbon atom in our DNA, every oxygen molecule we breathe, was once formed in the fiery core of a star like Betelgeuse. It's a humbling reminder that we are, quite literally, made of star stuff. But the story of element creation in stars like Betelgeuse doesn't end with carbon and oxygen. As a star nears the end of its life, the fusion processes in its core create an array of heavier elements. The catch, however, is that creating elements heavier than iron requires an immense amount of energy, more energy than the fusion processes in a star can provide. So, where do these heavier elements come from? The answer lies in the spectacular death of a star, a supernova. Now, imagine Betelgeuse nearing the end of its life cycle, ready to go supernova. This event is not just a stunning astronomical display. It's a cosmic forge where elements heavier than iron are created. During a supernova, the star's core collapses under its own gravity, and the subsequent explosion spews these newly formed elements into space. Elements like gold, platinum, and uranium are all products of this stellar explosion. It's a process known as nucleosynthesis, and it's how the universe enriches itself with the diversity of elements that we find on Earth and elsewhere. But the influence of a supernova like Betelgeuse's potential explosion goes beyond just creating elements. The shock waves from the explosion can trigger the formation of new stars and planets. As the expelled material from the supernova collides with surrounding gas and dust, it can compress these clouds, jump-starting the process of star formation. In this way, the death of a star like Betelgeuse can lead to the birth of new stars, continuing the cycle of stellar evolution. Now, let's delve into a groundbreaking discovery that has stirred the astronomical community. Have you ever considered the idea that a star, much like a celestial giant, could consume its smaller companion? Recent studies have suggested that Betelgeuse may have experienced a dramatic and violent past, one involving the consumption of a smaller companion star. This hypothesis might be a crucial piece in solving the puzzle of Betelgeuse's current state. To grasp the significance of this theory, we need to step into the world of binary star systems. In the universe, stars are often not solitary entities. They exist in pairs or groups, gravitationally bound to each other. Betelgeuse, it seems, might not have been an exception. The theory posits that at some point in its past, Betelgeuse and a smaller star orbited each other. Over time, as Betelgeuse expanded into a red supergiant, it might have engulfed its companion. But what would be the telltale signs of such a cosmic event? Astronomers look for clues in the star's behavior and composition. These clues include its rapid rotation, asymmetrical shape, and significant mass loss. Let's break down these phenomena in layman's terms and understand what they reveal about Betelgeuse's past and future. Firstly, let's consider Betelgeuse's rapid rotation. Generally, as stars age, they tend to spin more slowly due to various astrophysical processes. However, Betelgeuse bucks this trend. It's spinning faster than we would expect for a star of its age and size. Now picture two ice skaters spinning together. When they pull each other close, they spin faster. Similarly, if Betelgeuse consumed a companion star, the angular momentum of the smaller star would transfer to Betelgeuse, causing it to spin more rapidly. Next, there's the curious case of Betelgeuse's asymmetrical shape. Stars are generally expected to be mostly spherical, shaped by the equilibrium between the outward pressure of nuclear fusion and the inward pull of gravity. However, observations of Betelgeuse have shown that it's not a perfect sphere. Instead, it's somewhat squashed, with a bulge on one side. The asymmetry in Betelgeuse could be a result of its increased spin rate, distorting its shape due to the centrifugal force generated by rapid rotation. This distortion could be a lingering after effect of the merger, an astronomical echo of its tumultuous past. Finally, we come to the significant mass loss Betelgeuse has experienced. Stars like Betelgeuse in the final stages of their lives naturally lose mass in the form of stellar winds. But Betelgeuse has been shedding mass at an unusually high rate. It's as if the star is rapidly losing weight, throwing off material into space. This extreme mass loss can be a consequence of the star's increased energy output following a merger. The added energy from the companion star could cause Betelgeuse to become more unstable, leading to increased stellar winds and, consequently, a higher rate of mass loss. Understanding these phenomena helps us piece together the life story of Betelgeuse, from its birth to its eventual explosive demise. The star-swallowing theory also has implications for our understanding of supernovae. If Betelgeuse did consume a companion, the extra mass gained from this event could hasten its journey towards a supernova. This added mass would fuel the nuclear reactions in the star's core, potentially leading to a more powerful and element-rich explosion when Betelgeuse eventually goes supernova. But what would a supernova explosion mean for us on Earth and our understanding of the universe? Firstly, the impact on the night sky would be nothing short of spectacular. Betelgeuse, already one of the brightest stars in our sky, would illuminate the heavens with an intensity unparalleled in modern history. It would be so bright that it could be visible during the day, turning the sky into a stage for one of the most breathtaking celestial events human eyes have ever witnessed. For several weeks or even months, Betelgeuse would dominate the night sky, outshining the full moon and becoming a beacon visible from almost every corner of the globe. But what about the impact on Earth? There's a common concern when discussing supernovae: the potential for harm to our planet. However, in the case of Betelgeuse, we're in luck. Located about 700 light-years away, Betelgeuse is far enough that its supernova would pose no direct threat to Earth. The radiation and cosmic material ejected from the explosion would not affect our planet in a harmful way. Instead, the supernova would be a grand spectacle and a scientific bonanza, but not a cause for alarm. Now, let's turn our attention to another remarkable event in the cosmos that offers a unique perspective on the fate of Betelgeuse: the 2002 event of V838 monocerotis. This star, located about 20,000 light-years from Earth, underwent a dramatic and unexpected outburst, becoming one of the brightest stars in the Milky Way for a brief period. The event was characterized by a stunning light echo, a phenomenon where light from the outburst is reflected off surrounding dust clouds, creating a spectacular visual effect that can be observed for years. What makes V838 monocerotis particularly relevant to our understanding of Betelgeuse? Both stars are red supergiants, and both have exhibited unusual behavior that has puzzled astronomers. However, there are significant differences. The outburst of V838 monocerotis is thought to be a result of a rare type of stellar event, possibly a merger with another star or a planetary companion. In contrast, the fluctuations in Betelgeuse's brightness are believed to be due to a different set of factors, potentially including the absorption of a companion star. Still, the phenomenon observed in V838 monocerotis provides a compelling parallel to the star-swallowing theory associated with Betelgeuse. These events can have a profound effect, such as dramatically altering a star's life cycle, affecting its size, brightness, and lifespan. In addition, they can trigger unusual stellar behavior, as seen in the case of V838 monocerotis. The star's outburst was unlike anything previously observed in a red supergiant, contributing to the diversity and complexity of stellar evolution. As we delve into the mysteries of Betelgeuse, it's essential to place it within its broader cosmic context, the Orion constellation. Known as the Hunter, Orion is one of the most recognizable and storied constellations in the night sky. It's not just a collection of stars, it's a celestial landmark, a guidepost that has guided humans for millennia. At the heart of Orion lies its most distinct feature, Orion's belt. This linear arrangement of three bright stars, Alnitak, Alnilam, and Mintaka, forms a line that has captivated skywatchers throughout history. But how can one find Orion's belt in the night sky? Winter in the northern hemisphere offers the perfect opportunity. As the nights grow longer, Orion begins to climb higher in the sky, making its appearance in the late evening. To locate Orion's belt, first, find the brightest star in the sky, Sirius. From Sirius, trace a line upward to find a prominent vertical row of 3 stars. This is Orion's belt, a gateway to exploring the larger constellation of Orion. Now let's focus on Betelgeuse itself, a star that has captivated astronomers and laypeople alike. Betelgeuse is not just another bright star. It's a red supergiant, one of the largest stars visible to the naked eye. If placed at the center of our solar system, it would engulf the inner planets, reaching out nearly to Jupiter. This enormous size is a clue to its advanced stage of life. Betelgeuse is a star nearing the end of its evolutionary journey. But what exactly does it mean to be a red supergiant like Betelgeuse? This classification is not just about size, but also about a star's place in its life cycle. Red supergiants are stars that have exhausted the hydrogen in their cores and are now fusing heavier elements. In Betelgeuse's case, this means it's burning helium into carbon and oxygen, a process that signals a star's old age in cosmic terms. This process is a common phase in the life of a star, but Betelgeuse's sheer size places it in the upper echelons of stellar giants. The red in Betelgeuse's title is also significant. This hue is a result of the star's relatively cooler surface temperature compared to smaller, younger stars like our Sun. Betelgeuse's surface temperature is about 3,500 Kelvin, much cooler than the Sun's surface temperature of about 5,800 Kelvin. This cooler temperature gives Betelgeuse its distinctive red color, making it a standout feature in the constellation Orion. In addition, the size of Betelgeuse is not just an astronomical curiosity, it's a window into the life of massive stars. These giants live fast and die young, at least in cosmic terms. Betelgeuse is estimated to be only about 10 million years old, a blink in the universe's timeline, yet it's already nearing the end of its life. This rapid evolution is typical for massive stars, which burn through their nuclear fuel at an astonishing rate compared to smaller stars like our Sun. But why is Betelgeuse so significant in astronomy? Its status as a red supergiant near the end of its life makes it a key subject for understanding stellar evolution. The processes occurring within Betelgeuse are representative of what happens to all stars of similar size and mass. By studying Betelgeuse, astronomers can gain insights into the life cycles of countless other stars across the galaxy. Moreover, Betelgeuse's variability in brightness is of particular interest. Typically, Betelgeuse ranks as one of the top 10 brightest stars in the night sky, but its luminosity is not constant. It varies over time, which is relatively unusual for stars of its type. This variability is believed to be due to a combination of factors, including changes in the star's size and temperature, as well as the presence of giant convective cells on its surface that can cause large portions of the star to darken or brighten. In the broader context, Betelgeuse's presence in the night sky has been a constant for human observers throughout history. It's a part of our shared cultural heritage, featuring in myths and stories across different civilizations. Ancient astronomers were drawn to its bright red color and apparent variability in brightness. For example, indigenous Australian cultures viewed Betelgeuse as a key part of their celestial lore, often associating it with stories of creation and the cycles of life and death. In Western astronomy, Betelgeuse has been a subject of fascination since antiquity. The name Betelgeuse is derived from the Arabic phrase Ibt al-Jawza, meaning the hand of Orion. Its size and relative proximity to Earth have made it a prime study target over the centuries. Using modern telescopes and imaging techniques, astronomers have been able to observe features on Betelgeuse's surface, including giant star spots and gas plumes. These observations provide valuable data on the behavior and properties of red supergiants. Furthermore, Betelgeuse has played a pivotal role in the development of various astronomical methods and technologies. For instance, it was one of the first stars whose diameter was measured using interferometry, a technique that combines the light from multiple telescopes to obtain images of high resolution. These measurements have given astronomers crucial insights into the star's physical characteristics and how they change over time. As we continue to observe this red supergiant, each piece of data we gather adds to our understanding of the life cycles of stars and the workings of the universe. Thanks for watching this episode of Beyond Discovery. Don't miss the video you see on your screen. You won't believe it.